So we'll be looking at inverse Laplace transform. Our previous class, we learned Laplace transform of various functions. So today we'll be looking at inverse Laplace transform. And after this, hopefully we learn how to solve differential equation if you are not too overwhelmed with everything. Okay, remember that we define Laplace transform. Hold on. Remember that we define Laplace transform of a function of t to be a function of s. Yes or yes? That is integral from 0 to infinity e raised to power minus st f of t dt. And remember that the Laplace transform of a function of f of t, you always give me f of s. Do you remember? Hello, are we together? Are you there? I can't hear you. Hello, I can't hear you. Wow. Hello, can you hear me? I can't hear you. Let me stop the recording.
Can you still hear me?
Yes, I can hear you. Can you hear me?
I can hear you now.
You were not talking. Okay, yeah. I said, remember that.
I was talking about connection.
Okay. We want to do inverse Laplace transform. Remember that yesterday we learned that the Laplace transform of a function will always be a function of s. That's why if you find Laplace transform of any function, you'll be seeing something like s there, s, and so on like that. So whenever you find the Laplace transform of a function of t, you'll be having f of s. Now, it means that if I find the inverse Laplace transform of this function of s, surely I'll be having f of t. Do you believe that?
Yes.
Exactly. This is what we call what inverse Laplace transform. For example, recall. Now look at this example now. Check. This is what we call the inverse Laplace transform. Inverse Laplace transform. Now let's look at some example. You call that yesterday the Laplace transform of cosine of at. What is that? If you can remember,
that would be s over s squared plus omega squared plus a squared.
A squared. Thank you very much. So that means that the inverse Laplace transform of this function of s will actually give me what? Cos 80.
Cos 80.
Are we together? Please understand this thing very well. You can see. It's mean I will just bring cos and whatever I have there, then I'll put t. That's cos 80. Also, similarly, we learned that the Laplace transform of sine 80 is equals to a over s squared plus a squared. So now this one, we want to do something. We want to play a game here. What is the inverse Laplace transform of a over s squared plus a squared? What do you have?
Sine 80.
Sine 80. Now I want to play one game with you. Oh, yeah, now check the game here. Hey, sorry. Now check the game. It can be so tricky. What is the game? Check. If I ask you that, okay, what is the inverse Laplace transform of 1 over s squared plus a squared? What you learned here was a, but now it's now 1 over s squared plus a squared. What will be my answer?
The answer would be sine t.
Sine what? C.
Sine t.
No. It's not. What will it be?
1 over s squared plus a squared.
Yes, the inverse Laplace transform of 1 over s squared plus a squared. Do you know what the answer will be? Oh yeah.
Sine
now
plus.
I will not teach you. Now pay attention. Recall that inverse Laplace transform of a over s squared plus a squared is equals to sine 80. Do you believe that?
Yes.
Do you believe that? Now, I'm coming. Now, don't forget that this A is a constant. I can move it outside. So I have A inverse Laplace transform of 1 over s squared plus a squared. Of course, this is something that was sine 80. Are we together? We are divided both side by A. Inverse Laplace transform of 1 over s squared plus a squared will be equal to what? That's 1 over A sine 80. Do you see that?
Yes.
Exactly. It means that, see, why did I not do that for cos? I will tell you why. I can't do that for cos because this s is not a constant. It's a variable. Are we together?
Yes.
So I can never dare bring out s. I can only bring out a. Are we together?
Yes, sir.
Please take note of that. So we have inverse Laplace transform of various functions. Okay, if I tell you that, what is the inverse? Okay, what is the Laplace transform of e raised to power 80? What do you see?
Laplace of e raised to power 80.
1 over what? 1 over s minus a. Abina?
Yes. 1 over s minus
It means that the inverse Laplace transform of 1 over s minus a, what will it be?
Exponential
what? 80. Also, the Laplace transform of e raised to power minus 80 is equal to 1 over s plus a.
S plus a.
It means that the inverse Laplace transform of 1 over s plus a will be equal to what? E raised to power
minus 80.
Exactly. Nice one that you've known all this. Okay. Now, don't forget that whenever we are doing the Laplace transform of t raised to power n, our Laplace transform is n factorial over s raised to power n plus 1.
Yes.
Nice. Okay. If I ask you that, what is the inverse Laplace transform of n factorial over s raised to power n plus 1? What do you tell me?
T raised to power n.
T raised to power n. Now, another shocking. Let me shock you again. This person talking is in dramatic art. She cannot relate all this. Okay, let's go. Now, see this thing now. What is now the inverse Laplace transform of 1 over s raised to power n plus 1? Now, without the n factorial, what do you do? What will my answer for this?
T.
What will my answer?
I said T.
Yeah. Okay, let's do a game here. Yeah, this is a constant. Sabina, n is a constant.
Yes.
Yeah, bring it out. What will remain here will be 1.
Yes.
Then divide by n factorial. So what will my answer?
T raised to power n.
T
raised to power n over n factorial.
Fully. That's it. That's what t raised to power n divided by n factorial. Exactly. That's it. Because most time you will not be seeing it. That's what I'm giving you. You see, pay attention to this thing very well. Because you cannot be saying that, okay, you want to find the inverse Laplace transform of 1 over s raised to power 4. So yeah, what will be my answer here? Remember, I can do this thing as inverse Laplace transform of 1 over s raised to power 3 plus 1. So what will be my answer from here? Now, let's mimic what we have here. Oh yeah, what will it be? T raised to power what?
T raised to power n.
My n here now is now 3.
It's now 3 years. Over 3 factorial.
3 raised to power 3 over 3. Exactly. This is what you'll be saying. Most time you'll not be saying that n factorial because these things are just constant. Nice. So all these things are the preamble. Now that you've known the preamble, now let us now solve the question. What is the question? The question is find the inverse Laplace transform of this they give something like this: s plus 1 all over s squared plus s minus 6. I want to get that.
Yes, sir.
Now, let's go. You see, what you are going to do here is that check. We have to separate this like a whole fraction. If you observe, whenever we are doing Laplace transform from our previous lesson, you observe that we always simplify all the fraction and find the LCM. Have you now?
Yes.
Now, remember this fact that reverse of LCM is partial fraction. Yeah. Reverse of LCM is partial fraction. If you want to reverse the LCM like now, you have to do partial fraction. Now, don't forget, I have s plus 1 all over. If I factorize this denominator, okay, I'll be having
plus
s
3
plus
s
3
minus 2.
sounds exactly. So this is what we have. In partial fraction, what do we say? A over s plus 3 plus b
Plus 3 over s
2.
minus 2.
Okay, in a short way, to find A, I'll pick this numerator divided by the denominator of the second one. Are we together?
Yes.
Wait, let me see if I'm still recording. Yeah, I'm still recording. I'm coming. Let me still confirm. Yeah, I'm still recording. Nice. Okay, you pick this numerator to find A. This is a shortcut. If you know any other way, there's no problem. Pick this numerator divided by the denominator of the second variable, which is of the second constant, which is b. So divided by s minus 2. Then you are going to set the numerator of A to be 0. So s plus 3 is 0, s equal to minus 3. Then you now substitute it here. So what do you have? A equal to what? What do we have?
That would
Minus
be
3
minus
plus 1
3 plus 1
over
over
minus 3
minus 3 minus 2.
Exactly. So what do we now have here?
That would be
Minus
minus 2 over minus 5.
And that's what? 2 over 5. I mean,
Yes.
nice. Next, let's find our B. To find B, same way. I'm coming.
S plus 1.
I'm
Are
coming.
you still with me? Okay.
Yes. To find B, what do you have?
Now, s plus 1 over s plus 3. And then we'll set s minus
S
s
minus
plus 1
2.
over s plus 2.
Remember, we are finding B. That's
S plus 1 over s plus 3.
3. Then you set this
Then
to
we
be
set
0.
s minus 2 equals to 0.
S equal to 2. So therefore, my B is equal to 2
3
plus 1 over 2
over
plus 3.
5.
So what do I answer? 3 over 5 exactly. Now we've done this already. What's the next thing? The next is now to say, okay, so the inverse Laplace transform of what they asked us to do, s plus 1 over s squared plus s minus 6, is now the same thing as me finding the inverse Laplace transform of. Now, don't forget my partial fraction. What was my A? My A is 2 over 5.
2 over 5. Yes.
So I have 2 over 5 over. What's that numerator? What's that denominator of
S
A?
plus 3.
S plus 3. Then plus, what is the inverse Laplace transform? That's B is 3 over 5. I mean,
Yes.
over
S minus 2.
Exactly. Remember, this 2 over 5 is a constant. It can move out. And this 3 over 5 is a constant. It can move out. Inverse Laplace transform of 1 over s minus 2. Now, don't forget, look at this. What's the inverse Laplace transform of 1 over s plus 3? Wait, don't cram. Come and look at this thing. Look at this part. Where I treated exponential. Now check. S plus 3. Now, see what you're having. Do you see this thing? Inverse Laplace transform of 1 over s plus a is what? Exponential minus a. Are you there?
Yes.
And the inverse Laplace transform of 1 over s minus a is exponential at. Are you there?
Yes. Yes.
Good. Oh yeah, let us now apply that same principle. Let's apply that same principle. So what do we have here? So 2 over 5. So what my answer here? Exponential
minus 3t.
Nice. Plus 3 over 5. What do you have here? Exponential.
Exponential 2t.
2t. Nice. And remember that 1 over 5 is common to both of them, right? This over 5. So I can just be the 1 over 5 out. 2 exponential minus 3t plus 3 exponential 2t. Shikena. Done. That's it.
Yes, sir.
Since you've learned how to find inverse Laplace transform, it means that you can solve a differential equation with Laplace transform. Very possible. So this is how to find inverse. It could be complicated than this. But if you see any other one, try to attempt. If you did not get it, give me. You understand?
Noted, sir.
Yeah. There are different confusing ones, but just now, next. We now want to learn how to solve differential equation using Laplace transform. Now, to now solve differential equation with Laplace transform, you see that you'll be combining your knowledge on Laplace transform and your knowledge on inverse Laplace transform. And take note, the type of equation you can solve with Laplace transform up to the level I've seen based on my experience so far, you'll be given some initial condition. All together?
Okay.
Yeah. You'll be given some initial condition. Okay, let me look for a question. Now, solve. Let me see if I can see a challenge here. Okay, let me just solve. Solve for y of t, given that y prime prime plus 9y equal to 0, which you can see initial condition will be given, something like this. And y prime of 0 is equal to 2 using Laplace transformation. Using Laplace transformation. Now, check this question out. So we want to solve this with Laplace transform. All together? Are you there?
Yes, sir. Yes, sir.
Okay, so what's the first step? Now, we want to solve this differential equation, y prime prime plus 9y to equal to 0. So the first thing you are going to do is that, firstly, you are going to find the Laplace transform of each of everything you have here. Now, let's go. I have the Laplace of y prime prime, second derivative, plus 9 Laplace of y equal to 0. All together?
100%. 100%.
Nice. Now, the notation I'll be using here will be a little bit confusing, but it is just the same thing. Now, pay attention. Remember, when I was doing the Laplace of f of t, I was saying it is a function of s, f of s. I've been now.
Yes.
So similarly, if I'm doing Laplace of something like y now, I'll be saying it is y of s. Okay, it's still the same thing.
Yes.
Okay.
Yes.
Good. Now, don't forget that the Laplace of second derivative, can you remember? F prime prime of t. Let me remind you, is what? S square f of s, are you there? Minus s f of 0, are you there?
Yes.
Then minus f prime
Minus
of 0.
f prime of 0. Okay. Yes.
Exactly.
Yes, I remember.
I want to do that same thing here, which is what? S square. Instead of me to say f of 0, I'll say y. And instead of me to say f of s, I'll say big Y of s. Are we together?
Yes.
Then what again? Minus s y of 0. Are you there? You see this f of 0, you see small letter f. Are you there? Which
Yes.
means that function. So this one y of 0. Then what next? Minus y prime of 0. Are we
Of
together?
0.
9.
Yes.
Then plus, I have this 9. What is the Laplace transform of y? Y of s. Are you there?
That's big Y of s.
Equal to 0. Good. Now, don't forget, from this initial condition, what is y of 0? Y of 0 is equal to what?
0.
Good. What is y prime of 0 equal to? 2. Nice. So I'll just say what I'm having here is s square y of s. What's y of 0? 0, right?
Yes.
So this guy here is 0. Good. So what's y prime of 0? What's y prime of 0? Y prime of 0 is what? 2, right?
Yes.
Then plus 9 y of s equal to 0. Now, what you will now do next after this is that factorize your y of s out. I'll be having s squared plus 9. Are we together?
Yes.
Equal to, now check, this minus 2 can come to this other side as 2. Do you know that?
Yes, 100%.
Then what will you now do from here? Very simple. What you have here is y of s equal to 2 over s squared plus 9. Are we together?
Yes.
Now, Pay attention. What will you now do from here? It's very easy. Now, remember that what you want to find is y of t. It's like, check. I know f of s already. Remember that you have to find the inverse Laplace transform of f of s to get f of t. Are we together?
True.
Similarly, you have y of s. You have to find the inverse Laplace transform of y of s in order to get your y of t. Are we together? That's to get the solution to the differential equation. Are we together?
Yes.
Good. So what will you now do from here? Now, let me solve it. So you now be saying that, okay, no, let me continue my black. So what will I now have here? So the inverse Laplace transform of y of s, they take the inverse Laplace transform of both sides. What do you have? This is a constant. I can move it out. 2 inverse Laplace transform of 1 over s squared plus 9. My 9 can be written as 3 squared. Do you know that?
Yes.
Good. Remember, inverse Laplace transform of this is y of t.
Yes.
Yeah, that is my solution equal to 2. Don't forget, what's the inverse Laplace transform of something like this? Wait, let me remind you. That I told you that you'll be seeing something of this form very well. Yeah, now look at it.
Exponential.
Check. Oh, this is this. Look at it. Something like this.
Yes.
So which are you picking? Is this sine or cos? Sine.
Yes, sine. 1 over a.
1 over a sine of 80. Do you see that?
Yes.
1 over a sine of 80. 1 over a sine of 80. Exactly. So what do you have here? 2. The inverse Laplace transform of this is what? 1 over a. What is my a here?
A is 3.
Exactly. This is my what? A. Therefore, I have what? 1 over a. 1 over a, which is 3. Which is 3. Then sine of 80. Sine of 30. It means that the solution to this differential equation is 2 over 3 sine 3t. That's the answer.
Yes.
As simple as that. So let me now summarize the step for you. To solve with Laplace transform, firstly, take Laplace transform of everything. After that, substitute your initial value condition that you were given. Your initial condition. Substitute again. Find Laplace transform of everything. Substitute your IVP. After that, factorize y of s out. Then take the inverse Laplace transform. That's just the step. Is that clear?
Yes, sir.
So that's the end of the Laplace transform and everything. Yeah.
Oh, why don't Laplace like that?
Like yes. Like that.
Yeah.
Free of charge. Yes. This is everything, in fact. And also, let me add this. Okay, wait, I'm coming. Let me add some things for you. There's something I want to add. Let me see. Okay, I think that's all. Yeah, that's all.
I thought it's something.
So the thing that just to be solving question. What do you say?
I said it's not even hard.
It's not hard at all. Yeah, it's not hard. And it's not hard because our lecturers did not consider everything. There are some students I thought engineering matter. They even do it to the point whereby they'll use it to evaluate integrals. But all those things are not necessary for engineering. Are we mathematician?
Okay.
Although we know math, but we are not mathematicians. All right, so that's it. So there are some other transform again that those ones they're not going to it explicitly like that. So we can just talk about that now. Maybe anytime we're having this one. It's about Melling transform and Ankel transform with Fourier transform. All together.
Our next class?
No, that is any time that we'll be having. I think our next class will be AE. Now take this assignment. Or you want our next class to still be this?
No, AE, please.
Okay. Assignment. So you have to solve this Laplace transform y prime minus 5y equal to exponential 5x. They gave you y of 0 equal to 0. Solve using Laplace transform.
Can you still hear me?
Yeah, what are you saying?
Okay. I was just confirming.
Yeah, that's the assignment. That's the assignment. Okay, that's the assignment. After you'll be moving to somewhere very, very hard, like We are going to the hardest part of this thing. Kai. Okay, no, Allah.
We're almost done.
We're almost done with
done.
this part. We're almost done with this
Yes.
part.
Yes,
Wow,
I
that's
think
nice.
I checked it
Okay, good.
yesterday or
So,
thereabouts. It remains just to
so
copy.
jot down this.
Yes, yes.
So that's the end of the class for today. Okay, now take care.
Yes. Thank you so much, sir. Yeah.
Yeah,
Wa alaikum salam.
I'll send a note to you too.
All right, sir. Thank you.
So bye.